Hey guys, this is Garrett Wong, also known as Ensign Harry Kim from Star Trek Voyager, and you're watching Astronomy Live.
T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Stop.
Hello, welcome. Tonight we're going to be chasing a winged star. And right now I'm just finishing up trying to make sure I'm pointed in the right area before we actually start some deep space imaging. Taking a test shot here, and I'm going to throw those coordinates into astrometry.net. So give me a minute here while I work on that. Right. So you might be wondering why. Why go after this particular object? What makes it so interesting? And what makes it so interesting is that it is one of a type of object that has been focused on by some as proof of Nibiru on Google Sky. But when they found their first object of this type, it seemed that pretty much all of these Nibiru channels stopped searching. They said, oh, that's it, that's the proof. We've got it. That's all we need. But that is an example of confirmation bias. So, I know you guys can't see anything just yet. 1 second. There you go. So, trying something a little different here in terms of the streaming. Thanks to Red's Rhetoric, I've got a HDMI capture card, and I'm actually capturing the view of my other computer that is actually running the camera, which I happen to know has issues whenever I bring up other windows like this Chrome window. It will probably ruin the next picture because there's some weird incompatibility between this camera and Windows 10. Oh, I long for the days of Windows XP where it actually worked. So, I'm going to wait for astrometry to complete its job and tell me where exactly I'm pointed to make sure I'm pointed at the right coordinates before we actually start delving into some long exposures here. So that is where I should be pointed. Okay. Success, it says. 2352. It's pretty close. Yeah, that's really quite close. It should be in this field of view. Let's see, what do we got? 3160, 1581. Okay, that is... to the right. Where are you? Okay, let's go back to my observing list. Located. So we're going for a variable star called V1515 Cygni. Okay, there's the calibrated image. I'm amazed that actually didn't screw up due to the Chrome window. Okay, and astrometry says what? It says, okay, that is 3160, 1580. I think it's this star right here. Oh wait, no, it might be this star up here. The orientation is a little confusing to me. So I'm trying to get my bearings right now using Astrometry's sky chart and what I'm looking at on Sky Safari Pro. So if I'm looking right, 3160, 1462 should be that one back there. Yep, it's that one back there. So I think my issue right now, well, first of all, let's try flipping horizontally. Okay, then that would be on the left side of the image, but it's clearly on the right. 3160, 1580 is my reference point right now, and that's definitely on the right side of the image. But then this little triangle that it makes curves down towards the bottom of the image. Whereas, according to what I'm seeing, okay. Okay, yeah, flip vertically. If I flip the chart vertically, then it all makes good sense. Yeah, everything makes sense. Okay, good, good, good. In that case, I'm pretty sure the object we're looking for is right here. Or somewhere in that vicinity, anyway. Everything else is lining up on Sky Safari Pro. So we should theoretically have a bright star available in the AutoGuide window. I'm going to take a short exposure off the AutoGuider. Okay, we do have a few bright stars, actually. If anything, that makes for an interesting little conundrum there, because I need to calibrate the AutoGuider still. And I can calibrate using the main imager as well, but I need a single star hanging out by itself. I've got a double star there that is pretty darn bright, but I need a single star. If I go down to a very short exposure, okay, I can isolate this star right here. One of the problems, though, is going to be I'm not sure how it's all going to move. Okay, I'm going to start running 0.5-second exposures. Okay, while it's... oh, I can't do that while it's doing that. Okay, that's fine. I need to make sure I take out the slack in the drives. Okay, the slack is definitely gone. Next thing I need to do is stop this down to, say, 0.01 seconds. I want to get it so that the exposure is so short that only the one star would be detected, hopefully. Alternatively, I could use this star down here. That might be the better idea. I think it is. So, unfortunately, I'm going to have to undo. Okay, I want to move east. I'm going to have to go south, which will put slack in the wrong direction, but I can take it out. So basically what I'm doing now is I'm lining up a star to calibrate this AutoGuider. This will run the adaptive optics unit that will take out atmospheric distortions and give us a very clean image. But to do that, it first needs to learn how to turn the image, or how the image is turned, how it needs to move the telescope in order to keep the star centered. And it's going to keep it centered very, very quickly to compensate for the atmosphere. So I need to give it plenty of runway with this one star right here. So I'm going to give it a little more runway because it's going to move it in the north direction, so I'm moving it in the south to give it plenty of room. It's going to move it north and east, I believe. Okay, that should give it plenty of room. Now I'm going to just focus on that area of the autoguider. So only the one star is visible. Beautiful. Let's crank up the exposure a little bit. Maybe a little more, just so it can solidly see that one star there. Okay, that's nice. And now I'm going to click on it. Alright, it's locked onto that star. Oh, I need to take out the slack. Almost forgot that. So I have to keep moving it north a bit until it starts moving, because there's some slack in the gears. And this is why the adaptive optics unit is so powerful, because there is no slack once the adaptive optics unit turns on. But I need to calibrate both the autoguider and the adaptive optics unit first. Okay, so we've got the star moving north, so slack is gone. Calibrate, calibrate drive. 5 seconds for x-axis, 8 seconds for y-axis. Sure, that sounds great. So hopefully it moves it east. Yes, it moves it east. Okay. And then move it back west. Moves it back west. Then it's going to move it north, which is actually to the left due to the rotation of the camera. And the camera's rotated deliberately to get these bright guide stars in the view to use for auto-guiding and adaptive optics. Okay, drive calibration successful. Excellent. So I need to make sure it's symmetrical about the y-axis. Because of the slack, it's not quite symmetrical, so I'm going to fix that. Oh, oops. That wasn't the drive calibration results. We need to do it for the drive calibration results, not the AO results. Those are old AO results. Okay, that looks good. So, click OK there. We're going to lock onto the star again, and we're going to calibrate the AO. So it's calibrating the adaptive optics unit, so it learns how to tilt. It's got a tilt-tip mirror, and it's learning how to tilt and tip the mirror to keep that star where it needs to be. Alright, AO calibration successful. So I'm going to leave that as is. Now let's turn off subframe and get a picture of the full autoguider view and put the stars back where they belong, sort of. Put things back where we found them so that our star of interest is still close to the field of view, or close to the center of the field of view. Should be in the field of view. Guide star lost brightness. Whoa, what happened there? Not sure why. But it couldn't quite detect the guide star that time. Let's try this again. Oh, yeah, that's too dim. Okay, I can't be quite that aggressive with it. Let's make it a little brighter. Let's try this one. Maybe this one's brighter. I'm not sure. Yeah. That's better. Guiding at 10 to 11 hertz. Okay, we're going to say autosave on. This is going to be with the auto guider. This is going to be 1x1 bend images. This is going to be 10-minute exposures, let's say. Oops. Oh. Abort. Yeah. Okay, I have to be careful here because I don't want to accidentally pull up another window or have Windows do anything. In fact, I should just close Chrome here because this is going to cause me problems. So, everything is cool. And now I can actually start the long exposures. So now it's taking 10-minute pictures of our star of interest, V1515 Cygni. So this is an interesting star because it is actually an FU Ori type object. And no, I'm not cursing at it. That is the type of object that it is. Embedded in this little nebula is a T-Tauri type star, a pre-main sequence star that experiences variability and flares due to material accreting onto it from an accretion disk. It has jets of material shooting out along the axes of that accretion disk that are blowing back and excavating a portion of the interstellar material around in that area, producing, at the end of the day, what looks like wings around the star. And this is not the only star of that type that you can find in the sky. In fact, it's not the one that most conspiracy theorists have latched onto as proof of Nibiru. As I said earlier, a particular star was found on Google Sky some years ago that looked like the description of Nibiru given by conspiracy theorists. This mythical object that has wings, it's a star, but it has wings, and is said to be a massive brown dwarf or planet that is coming into our inner solar system surrounded by a cloud of iron oxide dust, can only be seen in infrared, and will cause utter devastation to our planet in its 3,600-year orbit. Now, when they found that object, they stopped there and they said, "Hey, we found it. That's it. That's proof." They generally didn't stop to ask themselves, is it really unusual? Are there any other objects like it out there? Is there a known designation for it? They didn't ask any of those questions sincerely. And so the research that is being done on it is next to nothing when it comes to conspiracy theory channels. So why am I taking pictures of this object? Well, for one thing, there's a very bright moon out tonight. So it's not really a great night for doing some serious deep sky imaging of beautiful objects, eye candy, where you really want super dark skies to get the best possible picture and get a really pristine image of a nice deep sky object. That's pretty much out of the question tonight due to the moon. But it is a very clear night, and I don't get too many of those at the end of summer, or throughout summer really, here in Florida. So I want to take advantage of it. but I also don't want to blow it on an object that, while I may want to take a picture of it, will be ruined by the moonlight. So I decided to take a picture of this object because, for one thing, it is the same type of object as that which some conspiracy theorists have latched onto and claimed is Nibiru, and yet it's one that they haven't really tended to notice. So keep in mind as you watch the stream tonight, imagine yourself, especially if you're prone to believing these things are doomsday or something unusual coming into our solar system, if you're prone to believing those sorts of things, imagine yourself watching tonight with a host who is trying to tell you that that's exactly what this is. That they found something out there in space. A new mysterious object that matches the description of Nibiru. And ask yourself honestly, would you fall for it? At the end of the night, would you have found something compelling there if I had been someone who's trying to sell you on that notion? Because I feel like there's still a certain danger in the Nibiru community that no one has really stepped up to the plate as a Nibiru proponent who actually knows what they're talking about. I mean, really knows what they're talking about when it comes to astronomy. You get people like Claudia Albers, who has a PhD and claims to be an expert on these things, but in reality she actually knows very little about astronomy, and she makes pretty serious basic mistakes all the time, and the things she promotes are just crazy. I mean, honestly, I think she needs help. And you get others who claim to be experts but have no expertise whatsoever and no credibility. I haven't seen someone step up to the plate who is a charlatan who also knows what they're talking about. Because if they did, and they saw where the Nibiru community went when the first of these types of objects were found on Google Sky by their community. The first one, by the way, was known as RNO54, also known as GN05.39.2. It's got a variety of designations. Also known, the central star in that complex was also known as Tycho 1861-1988-1. Whatever name you want to call it, these are all designations of that object that they found on Google Sky. Somebody who really understands astronomy like me and perhaps has equipment like me that can actually take pictures of those objects, imagine if they were unscrupulous and said, these guys really like that. I can feed them more of that. Not only can I take pictures of that object, I know where to find other objects like it. Because that's in a class of objects called FU or I type objects. So later tonight, after I'm done imaging here, I'll see if I can pull up, maybe I can pull up while we're imaging on the streaming computer, an article that describes these objects from decades ago. And it lists that particular object, the same one they found on Google Sky, alongside others, like this one. And if somebody unscrupulous comes along who has equipment like that, like a Gil Broussard type character, who has a telescope and knows where to find objects like this, all it'll take is strapping a deep space camera to their telescope and taking pictures of more objects like this, and then just drip feeding it to you, week after week, month after month, one at a time, claiming that it's the same object each time and it's actually moving. In reality, there's multiple objects like this in this class of objects located throughout the sky, and you can see multiple examples on any given night. But tonight I'm just going to focus on this one and try to get the best possible picture of it. And we'll see what we find. I've never actually taken a picture of this particular object before. It'll be interesting to see how well the telescope does in imaging this object. Unfortunately, I also found that I had ice forming on the CCD when I chilled it to sub-zero temperatures. I need to replace the desiccant in the desiccant plug on the camera. And even if I replace it right now, it'll take hours, maybe a day, before the humidity is pulled out of the CCD chamber again, so I can't get down to sub-zero temperatures. Another reason not to really go for a beauty shot tonight. We're going for just something interesting to talk about and show, but no beauty shots, we're not trying to take the world's best image of the Horsehead Nebula or anything like that tonight. This is just for fun and education. Hey, Trippin'. Yeah, it's not, to me, it's, the problem is not the asking for donations thing as much. I mean, obviously a lot of those charlatans are motivated by the money, but the bigger issue is the disinformation to me, and the misleading people. And if somebody came along who had knowledge of these types of objects and saw where the community latched onto one of them, they could drip feed them additional objects and claim that they're actually moving, claim that it's proof that it's in an orbit coming towards Earth. If they got really clever, they would even rank them from smallest to largest in angular size and drip feed it in order so that it appears to be getting larger each time they show you another example, and all the while claiming it's the same thing. It's just moving from place to place in the sky. And of course, they would probably if they were really clever, they'd want to lie to you about where they are in the sky, of course, and try to make it consistent, the claimed locations consistent with an orbit that would bring it close to Earth. Again, you know, that's all doable, but it requires more skill than, you know, Nibiru Planet X channel has, or any of these other, you know, major channels, Paul Begley or whoever is selling you this kind of stuff. They generally don't have the experience or knowledge to do that to you. They have to play at a much lower level. But if you had somebody who's playing at that higher level, man, they could do some real damage to gullible people who don't know any better by showing them object after object of this type, claiming that it's all the same one and it's moving through space and it's coming towards Earth. So this is me getting ahead of that, really, and just trying to drive home the point that these objects are not actually in our solar system. They're not dangerous, and they've been known about for decades, and they're still being studied today, but they are not dangerous objects coming into our solar system. Well, that's a problem I'm going to have to fix. Apparently there's a 10-minute sleep on the monitor. Okay. Come on, stop taking the picture. The other issue is it's going to do an auto dark. I hope that didn't screw it up in terms of the monitor turning off there. Well, the stars look good. So, we'll see what happens with the auto dark here. Hopefully that goes off okay. That'll get rid of all these colorful pixels. Those are hot pixels. Just effective pixels. Every CCD has them, but you typically don't see them unless you're doing really long exposures of really dim things like this. Then they come out to play. So it's taking a 10-minute exposure now with the shutter closed to calibrate against that. The only thing that should be in that 10-minute long dark frame exposure are the hot pixels. Those will then be subtracted from this picture, and we should see a cleaner image. Heathen. And the red flag is when you ask them for sources or whatever verification, they ban you or call you a troll. Very true. Yeah. Copernicus thinker. They made a TV movie based on Asimov's Nightfall. Good example of fears of astro events. Then again, they sold comet pills when Halley's Comet came in 1910. Yeah. I mean, that's the thing. This kind of cycle is not new in human history, and I'm sure it will continue for generations to come, where people sell fear of astronomical events to profit from it, oftentimes based on complete misinformation. We're not talking here about real threats, potential threats in astronomy, things like asteroid impacts, comet impacts, or Carrington events, or what have you. We're talking about just made up nonsense that gives some people control over other people. Because if they're the only ones able to supply you with the information of this event, of course you have to rely on them. And of course, a large part of that community is all about sowing distrust of mainstream astronomers and anyone else who would lead you astray from the cult of Nibiru. So, after this calibration 10-minute exposure is done, hopefully it goes okay. Not screwed up by me messing around with the windows here. If that goes off okay, I will pause the imaging for a moment to try to turn off the automatic screen shut off. That's an interesting issue I hadn't considered when I set this up like this, where I'm streaming from a second computer using the HDMI from the actual computer controlling the camera. Is that if the screen shuts off, you lose the image for the stream. So, it's my first time trying it this way with Deep Sky Astronomy tonight. And it works well, I think. I think it'll solve a lot of problems that I would normally have. But I have to do something about that automatic timeout. Claudia's doctorate should be revoked. I mean, I guess I feel a little biased about that because I do have my own doctorate degree. And in my opinion, I feel like, and again, I'm probably biased, but I feel like there's a very tall bar that should be met to revoke someone's degree. But I understand the sentiment, and I'm not saying I disagree with the sentiment that, somebody who abuses their credentials to mislead other people should lose those credentials. But, and I guess it gets into a philosophical argument that is beyond the scope of this stream, but I feel like the main reason anyone's PhD should be revoked is if it turns out that they forged their research. If they fraudulently made up their data, that kind of thing. That is something for which I feel you should lose your degree. If it turns out you lied in your PhD and you forged the data that you wrote and defended. But for what you do after you get it, I feel like there's got to be a high bar there to revoke that. However, she resigned from her position at the university, and now she makes her living on YouTube, I guess. But it's clear from some of her postings that I think she needs help, honestly. If she's talking about pink skies, around sunset and sunrise being proof of Nibiru, like she's never seen a sunset before or a sunrise, that's just delusional, and I fear it's signs of mental health issues that need to be addressed there. So I don't think she's necessarily as insincere as others in that camp. Even her own husband, who I happen to know for pretty darn sure doesn't believe the things he spews or the things his wife spews, for that matter, Scott Cohn. I don't think he really believes the stuff. He just sells it because he knows he can make money with it. And I think he saw her as a goose laying golden eggs in that respect. But yeah, that's a whole nother issue. But even they aren't the ones focusing on this type of object usually. They tend to make up their own stuff. But there are others who claimed that this object in Google Sky, similar to the one we're imaging tonight, is Nibiru, and that it was previously covered up on Google Sky. There's a region in Orion that's missing on Google Sky, and actually it had nothing to do with that object. It's not where that object is located. That object was never hidden or missing on Google Sky. It's always been there. But there's been some misinformation online, lying and claiming that that area of the sky was previously missing from Google Sky, and then it was revealed, and there in that missing region was Nibiru, this winged star. So that's why I'm focusing on that tonight. Those were claims that tended to be made on alternative media sites of very low repute fake news websites, basically. So, Sean Carroll asks, that makes me question things. Why would anyone resign such a cushy position at a university for conspiracy madness? And see, that's part of what leads me to believe she's a true believer and actually does need help. I mean, if you just look at the trajectory of her claims, they started off under the color of science, appearing, it was all pseudoscience, but at least it tried to fit in as much as possible with mainstream science and just add a few things or tweak a few things. And it's gotten progressively crazier and crazier. And you might think, well, she's just scraping the bottom of the barrel and making up stuff, and that might be it, but I think there's more to it than that. Because she resigned, for my understanding, and I wasn't there, but from what I've heard, according to her own accounting of things from years back when this happened, it sounds like she resigned because, partly because she had issues with the curriculum, partly because she didn't want to give up the Planet X nonsense. And she defended it to her colleagues. Her colleagues tried to correct her on this and educate her on this and say, no, this is not, there's no Planet X. And that, in that sense, there might be some mysterious object or some unidentified planet beyond the Kuiper Belt, etc. But no, it's not. There's nothing sweeping into the inner solar system, darkening the sun on solar observing telescopes. This is what got her started, as she would point at things like the moon transiting the sun in the 2007 stereo behind images and claim that was Nibiru. No, it's the moon. And you can look at that any way you want to slice it. You can look at where the moon was predicted to be. You can look at the surface features of the object. They match the moon. You can look at the illumination of the object. It matches what the moon should have had due to Earth shine and the sun. So, in every way possible, it is the moon. But she claims, to this day, that it is Nibiru. She also claims that the SDO eclipse seasons are actually due to Nibiru draining the sun of energy. At least that's how she started out making those claims. And she apparently ran with those claims to her own colleagues. She defended those claims to her colleagues and said, no, I stand by these papers I'm writing that are not peer-reviewed, but I sincerely believe them, and all that. If she had just said, oh, I'm just having a laugh with people online, that would have been the end of that, I don't think anyone would have taken issue among her colleagues. I mean, they might have taken issue, but they wouldn't have, they wouldn't have thought she was crazy. At least they might disagree with her ethically, but they wouldn't think she was like nuts, but that's not what she did. Now, why is that over there? Let me move that window back this way, please. Sorry, I gotta move this window. I don't know why the autoguider went off screen there. That's not what I had in mind. So anyway, yeah, it's pure nuts. And so I guess at the end of the day she resigned because she chose this life of making up nonsense about Nibiru, or sincerely believing it but promoting this nonsense about Nibiru over teaching at the university. She has basically no peer-reviewed papers to her name, so she's not really a researcher, but she was a lecturer at university. Anyway, yeah, this object does have some cloudiness associated with it, very, very faintly. It's going to take some serious imaging to pull it out. Fortunately, it is near the meridian right now, so it's best time in the evening to observe it. There's also some nebulosity down here, which is kind of interesting. keep an eye on that. See what it matches up to in stellar databases. Where did it go? Here it is. Right there. That's an interesting thing right there. But I'm pretty sure that's not actually what I was trying to image, although it looks almost more like a winged star than the winged star does. Now, that may change after we do some stacking and get some more images on here. But first, I want to turn off the image auto timeout, so hang on, bear with me, guys. I just don't want to accidentally dox myself on camera. I'm a little nervous about working with this computer, with you guys seeing everything, because I don't have a second monitor on this computer to move things to basically avoid accidentally showing stuff. Power settings. Where's power settings? Power and sleep settings. So I'm going to stop imaging while I do this, because I don't want it to... okay. Screen, when plugged in, don't turn off ever. Never. Okay. And don't go to sleep. Good. Alright, that should fix that problem. Okay, let's get the autoguider running again. Alright, and we're zooming in on the star of interest, or at least where I think the star of interest is. Maybe it's this thing over here too, I don't know. We'll have to see. We'll have to do some astrometry on it. But it's somewhere in this vicinity. I think that's just a double star, but I'm not sure. Okay, and we're back to taking images. It looks like the autoguider, unfortunately the star that the autoguider is guiding on is directly on a hot pixel which has been subtracted by calibration, which is why there's a black spot right in the middle of the guide star. It's not ideal. It's just bad luck right there. Question is, do I want to really do something about it? Seems to be working fine, because it can see the guide star around that black pixel, but it's just a little less than ideal, I guess. Yeah, I kind of want to do something about it. I don't want to waste 10 minutes waiting for this picture just to find out it comes out blurry because the guider got screwed up by the guide star. Okay. Let's try it again. Just by virtue of the fact I shut off the image, it will have moved a little bit. Hopefully off of that star, off that pixel. Almost. Move it west a little bit. Just nudge it a bit. Just a bit. Actually, that one looks brighter now. Let's try this other one. Yeah, that works better. Okay. Let that run. And while that runs, I am going to pull up the article I found earlier on FU Ori type stars for you guys to read. Hey, Copernicus there. Yeah, probably won't do that one tonight, but some other night maybe we'll go for Uranus. Trippin, do you need great computer specs to run the software? I'm guessing you do. Actually, I need less computer specs to run this software. The problem is, this software is quite old, and it was not designed for Windows 10. It's not really super compatible with Windows 10, is the problem I keep running into. Anytime Windows 10 seems to do anything in the background, or I bring up a window in the foreground, it deposits light, for lack of a better term. It seems to leave residual light in the image, and I don't know what I can do about it. It's really quite strange. And actually, speaking of depositing images, after this image, there's another change I wanted to make. I meant to make it before the webcast, but I forgot. I want to save these images to my OneDrive directory so I can transfer them directly to my other computers and actually process the images while the imaging is going on. That'll be another nice change that will speed up the pace of things, I guess. But I can worry about that later. Here we go. From 1987, publications of the Astronomical Society of the Pacific, the ring-shaped nebulae around FU Orionis stars. See if I can pull up the PDF. Here we go. Now the question is whether OBS's browser will let me share this properly. Browser. I don't know if that will work properly. It may not. Let's see. Is there another way to get this? There might be another site that has it in a different format other than PDF. Yeah. Harvard has it. Here we go. Let's do this one. Okay, yeah. Sharing PDFs in the OBS browser, not the best idea. There we go. don't really want to cover up. Oh, well, I can do it this way, can't I? Just shrink it. Like that. Okay, I'll shrink that down because I want to monitor what's going on over there, how long the exposure is, what the pictures look like, all that stuff. But I also want this browser over here. Okay. Let's make that a little wider. Okay, cool. Now, interact. So I'm guessing this is probably a little hard to read on stream. I'll try to do my best to make it a little clearer. So this was published in 1987, so 32 years ago. And at the time, there were 5 known FU Orionis stars. I know there's more now, but back then there were 5 of them known, and all of them were associated with ring-shaped nebulae. It's not unique to FU Orionis, but is rather unusual among other young stars. So keep in mind, this is a scan of a black and white it's a black and white scan of a grayscale or black and white document, so the quality of the pictures they show is really poor on the PDF. It would have been better if you actually had the article in print, but these are just low quality scans of articles. So if I go down here to this page, this actually shows some example images, and B is actually, this is the object we're imaging tonight, and I know that looks terrible, just like a black smudge, but like I said, these are, you know, relatively low quality scans of black and white scans of the printed article. The preview picture for this live stream is actually of the same star we're imaging right now tonight. Also listed in this same page, number E, or letter E, is the exact same object that was pointed out on Google Sky. RNO 54 is what they call it in this article. It's also known by other names. The central star in that nebula is known as TYC, or Tycho 1861-1988-1, and the object is known as GN for Galactic Nebulae 05.39.2 in the Atlas of Galactic Nebulae. So there you go. And there's some other ring-shaped nebulae around some of these other objects too. And these aren't the only examples, but there are a number of them. And back then there were only 5 FU Orionis types known, I guess, but we know about more of them now, for sure. So it goes on to describe the observation of the reflection nebulae around stars 1057, V1515 CYG, V1735 CYG, blah blah blah. I wanted to pull up another article too that showed more recent information about one of these objects. And that was Parsamian 21. That's not listed on this article I'm showing you right now, but it is listed. It is listed in this article that was submitted to archive.org. I wonder if it's available from Harvard or some other source. That would be nice. I want some browser-friendly source, not a PDF, if possible. I may have to log into my university affiliation to get it. Oh, no, it's freely available. Excellent. Okay. Yeah. And this is one, Parsamian 21, is one I've imaged in the past. And it's even been imaged by the Hubble Space Telescope. So, very well studied object. So a lot of these others have not actually been imaged by Hubble, but this one has. It's not the one we're taking a picture of tonight. It is one I've taken a picture of previously. Alright, looks like the latest picture is about to be done and downloading. Hey, what? No! I didn't mean to do that. Okay, well, I goofed that up. Accidentally clicked something else and navigated away from the page I wanted. Try to reload that. Okay. I turn this off for a second. I'm going to stop taking pictures for a second. Autoguider, stop. Okay. And I'm going to change the autosave location to a new folder. Hopefully I've got my OneDrive on here. Do I? Yes, I do. I'm going to call this copy the couple of pictures I've already got over to that. Come on. Control C. Control V. There we go. Alright. And okay, now I can turn it back on.
Hey guys, this is Garrett Wong.
Wrong thing. There we go. Let's see, take image. Excellent. Okay. So, coming back to look at this article. Why can't I scroll? Should be able to scroll, but I can't. Huh. Well, that's not terribly helpful. I'm not sure why I can't seem to scroll, but it seems I can't. Let's try split view. Okay, there we go. It's a little bit narrow, but at least now I can scroll. So this is Parsamian 21, and I did see an image in here that showed a nice diagram of what these systems look like. They must have put the pictures way at the bottom, or must have passed it. Where is it? Maybe it's a separate link. Figure 1, yeah. Oh, there we go. So I have to click on the figures individually. So here's an image, a Hubble image of the object. You can see how it's got wings coming off this central star. It looks more like a central point in some of the other images. And keep in mind, this Hubble image is a negative image. It is reversed. So I'm trying to find... Here we go, figure 11. So this shows some of the configuration, the basic configuration of this system. So you've got an accretion plane, accretion disk in this plane, and you've got outflow along the axes, roughly perpendicular to that plane, but it's blowing back and excavating out this cavity from the interstellar medium. So that is the basic morphology, and that is why these systems tend to look that way. You see it in multiple examples. This is just one of them. Alright. So I just wanted to show that. Let's close that now. Go back to the video capture device. Let's go ahead and blow this back up. So, now for my next trick, I'm going to prepare to start stacking the collected images. They should be shared across the OneDrive to this computer over here. So I should just be able to drag and drop them in, which is nice. Huh. I'm not seeing it. Okay, the OneDrive must not have updated yet. Oh, the OneDrive is offline. Okay, at the risk of ruining this beautiful 10-minute image. Okay. Now it says OneDrive is up to date. I don't know why it moused over to it. It says it's up to date, but I'm not sure that maybe it's not updating on this end. Check my phone too. Cube-shaped object heading our way? Is that the Borg? I once got to briefly meet Dr. Gerald K. O'Neill, Princeton physicist, author of The High Frontier. As in O'Neill structures? Or what do you call it? O'Neill orbital habitats? I forget what the term is. That name rings a very strong bell, though. I feel like I should know that. Yeah, no, okay. Oh, there we go. Now OneDrive is updated. Hooray! Okay. Change raw fit settings. This is nice because now I can actually start stacking these pictures immediately. I don't have to wait till I'm done, because I can't mess with Windows while I'm actually taking the pictures on the computer that's taking the pictures, but I can deal with it on a separate computer. Huh. I don't know why the image shifted so much between the first picture and the second picture I took. Must have been because the tilt tip mirror was in some strange configuration, maybe? I don't know. But hopefully that won't really matter. If anything, the area I'm interested in is now closer to the center. O'Neill cylinders, that's the term I was thinking of. Space colonies, yeah. Mass driver to propel raw lunar ore to L5 locations to build space colonies. Yeah, that's awesome. Okay, so I did a preliminary stack off just the first two images, and I'm about to have the third here in a minute. I want to see for sure which star is it we are actually looking for here. I'm going to upload my stacked image to astrometry.net. And then overlay it on top of Google Sky to see which one we should be looking at. Star lost brightness. Well, yeah, because you close the shutter when you're done taking a picture. Guide star's right there. Alright, there you go. I'll make sure I didn't lose the guide star or something silly. No. Okay. Success. Alright, so successfully solve the image. I'm going to download the KMZ file and open it in Google Sky here and overlay it. We'll see what we're looking at. Oh no, Copernicus, I haven't checked my Astronomy Live email stuff yet, so sorry, I haven't seen that yet. Oh, it's an interesting concept there, Sean. Calculating temperature via the cricket chirps. I forgot about that. Isn't the periodicity of cricket chirps determined by their temperature or something, I guess? Could write a program to do that. I think I remember hearing something about that. Okay, let's see. Solved image. Zoom in on that. And okay. Yeah. Okay, let me stack the third image on there. Should be done now. Yep, there it is. Ah, it shifted again. It must have shifted in my downtime between exposures. But as long as I keep running the exposures one after the other, it should stay on that guide star and it shouldn't shift. My polar alignment was pretty darn quick and dirty tonight, so I wouldn't be surprised if there was a bit of drift. Okay. We've got 3 images stacked now. So I upload that. Chirps in 14 seconds and add 40 for freedom units. So, okay. Try median stack. Try to kill out some of the noise. I don't know if that'll make matters better or worse, but the stacking didn't really help. I don't think. It's just a little different. Okay, let's see if I can share this window. So I've got window capture, Google Earth. Oh, well, that doesn't work. Google Earth doesn't display properly with window capture. Note to self. I wonder if I could capture it with game capture. Just game capture. Act like. Does Google Earth act like a game device? Yes. No? Well, doggone it! Okay, well, we are looking at the right star anyway. New image came in. Let's stack that. Go back to maximum stack. I'm going to try and process the images I've got so far with PixInsight and see what I can pull out of the image. try to enhance the brightness and contrast a bit. See what I can pull out of this thing. Yeah, I'm starting to see one of the wings for sure. Okay, I'm doing some heavy anti-noise filtering on it. And I'm going to do one more pass on trying to adjust the brightness and contrast. that. Let's scale that up a bit. So this was with just 4 images stacked so far. It's not a very big stack, which is why it's also going to be very noisy. But I am able to pull out one of the 2 wings of this star. It's interesting the other side's not showing up yet. Maybe it lost a wing. I'm going to bring that into OBS now. So here is the stacked image, and it's the same. This star here is, well, you can see it's the same stars. I've just adjusted the scaling of it a bit, but the star in the center there is the star directly below it here that we're looking at, and you can see one golden wing sort of coming off the left side there a little bit. It's faint, but it's there. It's not just noise. That is actually what we're looking for tonight. Let me blow this up a bit. Click and drag. There we go. So you can see it there. Versus the live image. Of course, you can't see much in the live images. Just individual images don't show much. It's when you start to stack these things that you can start to pull out the dimmer features, which is why it takes so long on these objects here. We really have to collect a lot of light to detect the dimmer features. I'll just leave that there for now. I wish I could show, oh man, I really wish I could show Google Sky, but it's not capturing properly. Because it does overlay with Google Sky quite nicely and match up with Google Sky's version of this. But how's that look to you guys? Can you see that bit of wing there? I would imagine you can. And yes, this star is part of the Cygnus constellation. Or it's not part of the constellation, but it's in that constellation, within the borders of that constellation. try a slightly different way of handling the noise of the image. See if it helps. So that's a good question. So image stacking is used to refine detail, not remove noise in the image shown, or are there different algorithms used for different purposes? So it's a bit of both. You increase the signal to noise ratio by stacking. Noise is random in the image. Stacking removes that which is random and keeps that which stays the same. The signal is what stays the same. The stars are the same from image to image. The nebula is the same from image to image. So by stacking more and more, even if it's just a very faint signal, you'll pull it out of the noise eventually. But I also do additional noise denoising algorithms on top of the stacking to try to help things out and move things along a little faster, because otherwise we'll be here all night shooting this. I've got 5 images stacked now, and I'm going to try to apply a bit of denoising in a different way using GMIC, which I think has a pretty good, it's aggressive, but it looks nice for astronomy pictures. GIMP is currently in the process of locking up a bit. There we go. Does help a lot. That most certainly helps a lot. About to get a new image. Good. GMIC definitely saves the day. Kills the noise without killing the signal pretty well. So that image is saved. I'm going to go ahead and stack. So we'll have a full hour of images in the stack. Six frames, 10 minutes apiece for 1 hour of light. That's the minimum I like to have on any given picture. Okay. Let's save that. Oh yeah. Okay, we're starting to get the other side of the wing, I think. We'll see when I'm done processing here. The other side of the wing is definitely hiding in the noise a bit. But it is starting to appear, I think. So I will apply that to it. Excuse me. Yeah, now we're talking. Alright. Let me share this guy with you. We're starting to get a winged star appearing. So here's the magic of stacking. I'm going to shut off that image and replace it with this one. Voila! The winged star appears after stacking. So this is just 1 hour of light. I normally would like to add even more on that, and we'll add what we can. But, yeah, now it's actually growing wings, isn't it? So this is after stacking the first 6 images. You can definitely see, you can easily see the left side of the wing. Right side is just starting to appear now that we're adding more images, so you see the difference there between this and the previous one. I also changed the noise denoising algorithm. It's a little more aggressive, but it, I think, retains the detail you want to retain. So yeah, we're starting to see some of the right side wing grow out of the star, but as you can see, it's not symmetrical. It is stronger in terms of brightness on the left side. But as we add more to it, it should continue to grow. Not bad for a little 8-inch backyard telescope. Trying to compete with telescopes measured in meters. Professional telescopes doing all sky surveys. Of course, it also helps to have adaptive optics here. That is definitely keeping things nice and sharp for pulling out this tiny nebula, which extends thousands of astronomical units, but sitting here on Earth, I don't know, probably hundreds of light years away, at the least. You know, we're looking at something that subtends a very small area of the sky. Very, very, very small. Measured in arc seconds here. An arc second is 1/3600th of a second. This is much, much smaller than your typical nebula that you look at through your telescope. Even planetary nebula are usually bigger than this. So yeah, that's an improvement over the live images. What do you guys think? And this is why I say, you know, you have to be careful who you trust. Do your own research. I mean, this is a known object. It's been published about for a long time. I showed you guys that paper from 32 years ago, which mentioned this object and in the same category as that Google Sky Star. And you can see the similarity there in terms of the wings coming off of it. And as I add more images, it'll probably become even more similar. And you know, it wouldn't be too difficult for me to set this up as sort of an automated processing where it's automatically stacking them and just keeps adding to the stack as it downloads each image. Deep Sky Stacker Live is designed to do that, for example. It will automatically align and stack your images for you and just keep adding to the stack. So that would be one way to do this. Although ideally, I think I'd want to write my own program to add in my own denoising algorithms and stuff to it to make it a little easier to see. But yeah, even if I didn't want to write custom software, with just off-the-shelf as it were, free software, Deep Sky Stacker Live, you could do this kind of thing and just keep adding to the image, and just live stream like this. And you know, if you were an unscrupulous Nibiru channel, make absolute bank off of this, because your typical competing channel, whether it's another Nibiru channel or a debunking channel or whatever, is usually not going to have access to the kind of equipment needed to see this themselves and do anything about it. Of course, you could astrometrically solve the image and figure out where it really is in the sky. That's going to be difficult with the kind of magnification I'm showing here. With just these few stars, it's pretty sparse, and we're looking at a very tight field of view in this blown up image I'm showing you right now. It probably wouldn't solve in astrometry. It might, but it would be tricky. This is kind of at the limit of what astrometry.net can do in terms of minimum angular size. You typically need a couple arc minutes there, and this may not even amount to that much. So it would be a tricky solve to figure out where in the sky it was if I didn't tell you. But I've already told you, this object is V1515 Cygni. But if you were a dishonest channel and you wanted to hide that fact, all you'd have to do is zoom in on it, so there's not enough context to figure out where it is in the sky, and just keep streaming it, you know. That's the danger I see. So that's why I'm trying to stream this object and show that, hey, GNO539-2, that other winged star on Google Sky, it's not the only one. It's not unique. It's not abnormal, or it's not in a class of its own. There are other objects out there. And in case you're wondering, the black spots are dust on the CCD. Those are taken out by flat field calibration, which I haven't done yet because I don't have a flat field frame yet tonight to use. Yeah, FU Orionis stars are basically accretion disks around the central star. And the central star is usually a T-Tauri type star, pre-main sequence young star that hasn't yet entered the main sequence. It's still gravitationally contracting to generate its heat and light. How many light years away is this particular star? That's a great question. Let me look it up on Simbad real quick. Or actually, I wonder if, well, let's see. Parallax is almost exactly 1 milliarcsecond. Interesting. Let's see if that agrees with what Sky Safari says. Sky Safari doesn't tell me. That's interesting. So yeah, 1,000 parsecs, that is 3,261 light years. Yeah, it's almost exactly 1,000 parsecs away at 1 milliarcsecond, of course, because one arcsecond of parallax is 1 parsec. So yeah, about 3,261 light years. Alrighty, while I wait for more images to come in, I'm going to throw on some music here. And I'm going to go grab a bite to eat real quick, and I'll be back. What I want to do, I want to shrink this down a bit so we can all keep an eye on what's going on with the actual imager, just to make sure the stars aren't going out of round or anything crazy. Pull that back up. And I'll be right back. I'm gonna wrap it up for the night here shortly. Let's see. Oops. Don't want to do that. Trying to do that. Okay. And the last picture is in. Alright, let me stack what we've got and see what the final picture comes out like. That will be without flat field calibration, of course. That takes out the dust motes on the CCD. So the dust will still be there, but I will stack all of the images later. Let's see, the last one I had on here was number 9. So I got 10, 11, 12, 13, 14. So another 50 minutes. Oh, it's so tempting to get one more picture, because then it would be a nice even 2 hours. But I gotta get some sleep, so I'm gonna wrap it up for the night here. I'm not gonna take any more. Law of diminishing returns anyway. One more 10-minute picture is not gonna make much of a difference. But adding 50 minutes to the previous hour should make a difference, I think. So 1 hour, 50 minutes total. Okay, stack's done. I get to load that in Pixin site. That. Load it into GIMP. think that produces a much smoother image now, even without the dust subtracted, which I will do later. Oops. Do it to that layer. Curves, adjust, curves. There we go. Oh yeah, that looks nicer. Less noisy, at least. So I followed the same template of adjustments, same processing pipeline that was used for the previous image. Nothing changed except the number of images stacked. Well, and I might change the sizing of it a little bit, but just because I can't remember how exactly I sized it before. Alright, so you guys see the image up there on the top right now. That was the first hour of light. And here's what it looks like when you add another 50 minutes on top of that for almost 2 hours of light instead. So as you can see, less noisy, certainly more detail in the wings. A little more extension in the wings and a little more detail there. You can see still the right side wing is just sort of a nub, but it's there. And there you go. A slightly nebulous winged star. Courtesy of 2 hours, almost 2 hours of data from the telescope, tracking it with adaptive optics. So, any last questions before we sign off here? And blow that up to fill the screen. So the colorful pixels are just unsubtracted hot pixels. Normally I keep a library of dark frames at a particular temperature, but because I had to run the camera warm tonight at 5 degrees positive, I don't have a library that corresponds to that temperature. You want to subtract dark frames that are at the same temperature as the camera is actually running. So I had to do a dynamic dark frame subtraction, and that's just how it's going to have to stay. So there will be some unsubtracted hot pixels there. I can adjust that in post later, but that's why you see those pixels there. Dynamic dark frame subtraction is not as good as having a full library where you've taken 30 or 60 dark frames in a row, and then you catch more of the hot pixels that are there and are able to better subtract them. Also, the big dark circle at the bottom left and the other dark splotch up there at the upper left, those are dust motes on the CCD, which I will correct with flat field subtraction. Can I increase the zoom 10 or 20%? Was that before I zoomed it in all the way? Will this get closer in time towards Earth? Not really in our lifetimes. What does Simbad say for radial velocity? There's no radial velocity data, but it's over 3,000 light years away. It's about 3,200 light years away. So even if it were traveling at the speed of light towards Earth, which it is most certainly not, it wouldn't get here for not only centuries, millennia. But it's not. So no worries there. Nothing to worry about. Thank you, Copernicus. Thanks, Dance Houston. Last thing I wanted to do, I really want to overlay this on Google Sky just to show you guys what that looks like. So let me try one thing. If I can astrometrically solve the full uncropped image, processed as a JPEG, I should be able to download the KMZ file, open it in Google Sky, and then just do a full-blown screen share. Which I didn't want to have to do, but seems like that's the only way this is going to work. So astrometry.net is solving it right now. Hey, BM Furball, 2 hours late. Can I sum up the stream in one sentence? Yeah, F-U... No, I'm not cursing at you. F-U Uranus. Stars. So, I don't know if I could sum it up in one sentence, but I'll try to make it as pithy as possible. Basically, conspiracy theorists latched on to an F-U Uranus type object, which is a young stellar object with a T Tauri type star in the middle. It's a young pre-main sequence star which has a nebula associated with it from gas and dust from the accretion disk that gets ejected along the axes, the poles, and there's a ton of gas and dust that basically spews out from this thing and excavates a cavity out of the interstellar medium. And bottom line is it produces a ring-shaped nebula or wing-shaped nebula around a star, a young pre-main sequence star. This got latched onto because conspiracy theorists found one on Google Sky, which is known as GNO-539-2, and that for years has been claimed to be Nibiru. It's been claimed that it was hiding, that Google Sky was hiding it. They weren't. And it's not even a unique object. There are others like it. And that's what tonight was all about, proving that by taking a look at a very similar object, which is the same category of object, known as V1515 Cygni, which is another one of these FU Orionis type stars. And it can also be seen on Google Sky as a winged star. But it's not moving. It's still in the same place it was on Google Sky. It's over 3,000 light years away, and so it's just proof that these objects are not unique. There are multiple winged stars in the sky that you can see with a real telescope. It's not an image artifact, it's not a lens flare, it is a real object, but it's also not Nibiru. So that's what this stream is all about. Hope that sums it up succinctly enough. Now I will show Google Sky with the astrometrically solved image that I just have here on the screen overlaid on top of Google Sky, so you can see how well it matches up, and the fact that this object is clearly not moving relative to where it was in Google Sky. I'm also quite impressed, like, the stars you can see in Google Sky are all in my image. Like, I got down to the same magnitude as Google Sky does, which is kind of impressive for an amateur telescope. Alright, let's see here. Okay, this is going to end up creating a Hall of Mirrors effect. I'm going to try to mimic, or I'm going to try to minimize that as much as possible. Display capture. Display capture. Display 0. It doesn't like that. Why doesn't it like that? Come on, I thought for sure this would work. Try that again. Okay, I'm going to try... gonna try one more. Oh, wait. Does game capture work now? Game capture works now. Hooray! Okay, so doing a game capture off of Google Sky. Turn that off. Okay, so now here's the same image overlaid on top of Google Sky. And then if I fade out to the Google Sky background picture, you can see the same winged star is there in the exact same position. It hasn't moved. The other stars around it are all the same, as you can see. And there it is in my image. So yeah, doing this, uploading it to novaastrometry.net, you can download a KMZ file that you can open up in Google Sky and overlay your images back on top of Google Sky and see how they match up. It does degrade the quality of your images a bit, but it gets the job done, and you can see how it matches up anyway. So yeah, that's the stream, and there it is in slightly higher quality before I uploaded it for matching up with Google Sky. There it is, the winged star. So that's the stream for tonight. Any other questions? Maybe Claudia drank too much chili juice. Maybe that's the problem. Oh dear, that's a mistake no one should make. Don't drink the chili juice, folks. She responded to me, and peer reviews are used to keep the truth out of the academic method. Oh dear. So yeah, she has a problem with peer review because she couldn't pass peer review. That means she was making some serious mistakes. I mean, to be honest, there's a lot of garbage papers out there that have been peer reviewed in garbage journals that are very low impact. If you can't even get your article published in a low impact journal through minimal peer review, you are making serious mistakes and need to go back to the drawing board. The point of peer review is not to gatekeep the truth, as some think, because you can always go to low impact journals where more outlandish theories are accepted. The point of peer review is not to prove that everything in the paper is absolutely true beyond all shadow of a doubt. It is to make sure that other peers in the field, other experts, have looked at it and at least see that the methods were done properly, that there aren't serious errors or serious overreaching conclusions. But you can still have open-ended questions. You can still have theoretical theories in there. You can still put theories in there that aren't necessarily fully supported by the evidence, but suggest that maybe it's an explanation for the evidence. But there needs to be some sort of logical flow between your hypothesis, your methods, your results, your discussion, your conclusion. There needs to be some sort of flow there. And if you can't achieve that, you're going to get rejected, even from low-impact journals, especially if you're making serious mistakes, which she frequently does. So I'm not terribly surprised, but I'm just saying that it's not an excuse to say that it's some sort of evil mass conspiracy to keep the truth out. I've peer-reviewed articles. I'm a professional scientist myself. I have peer-reviewed 4 multiple journals. And you'd be surprised at some of the garbage that manages to get past peer review. That's not to say that all peer-reviewed articles are garbage. It's to say that in low-impact journals, garbage gets published quite frequently, but that's why it's a low-impact journal. Impact factor means how many times are articles in that journal cited. And if they're not getting cited, it's probably because the results have not been reproducible, meaning no one else has been able to confirm what that person is saying, okay? But if you can't even get to that point where the point of peer review, like I said, is to make sure that serious errors and gaps like that are corrected so that people can attempt to reproduce your results, right? If your results are not written in a way that anyone else could actually attempt to reproduce them, or if it doesn't make any sense at all, then it's not getting published. But if at least you've detailed things enough that even if what you've said is wrong, it is possible to test what you're saying, you can probably get it into a low-impact journal. But in her case, that's not happening. She just claims things out of the blue, like pink sky means Planet X is coming, means Planet X is here, and there, and then there will be like a SpaceX launch, and so she'll say it's proof that Planet X debris is hitting the atmosphere. She actually said that, and it was a SpaceX launch in the early morning. I was there. I filmed it myself. It was not Planet X debris hitting the atmosphere. But she'll just jump to these conclusions with no rational thought behind it. So it's no surprise to me or any other serious scientist that her stuff doesn't get past peer-reviewed, but it doesn't mean it's some grand conspiracy. So, anyway. I'll get off my soapbox now. Al, are those couple of green dots CCD artifacts or green stars? Those are CCD artifacts. Those are hot pixels. Keep in mind this is an expanded image here. This is blown up past the full resolution of the image, so the hot pixels look enlarged here. What is the deepest sky object I have captured? That would probably be that quasar, that very popular quasar. Was it 2C393, something like that? Or maybe it was 361? No, 2C, 3C, sorry, I got the numbers mixed up. 3C space 273. Quasar located in Virgo. It's about magnitude 12.9, so it's actually pretty easy to observe. And it's 749 megaparsecs, or 2.4 billion light years away. So that is definitely the furthest. Now, deepest in terms of dimmest magnitude, this one right here would probably be up there, I'm betting. Because this is a very obscure object right here in terms of the nebulosity of it. Is very dim. Let's see if I can get somebody indicating what the magnitude, not of the star is. The star is relatively bright, but the nebulosity around it. Let's see, is there a specific entry for... Here we go. The nebula around it is actually classified under the Atlas of Galactic Nebula as GN20.22.1. And they don't even list a magnitude for it. Holy crap. Pardon my language. Hashtag demonetized. Does anyone have a magnitude for this? I'm guessing it's not listed. It's not even listed. I mean, I don't even know. So yeah, the star is V1515 SIG, but the nebula is GN20.22.1. And there's only one reference for it in the merged catalog of reflection nebula. Let's see if this catalog gives me a Let's see if this catalog gives me a magnitude for it. I don't know if this is... Nope. Nope. I don't know. Dim, I guess, is the answer. So sorry, I still cannot find any. It's only available in electronic form at the CDS via anonymous FTP. Oh, well then that's not terribly helpful, is it? And I think it's just a merging of all these other nebulae. It's not really any new information on them. So no, there's no magnitude listed for it. But it's somewhere in the ultra dim category. Do I suspect there's intelligent life in the universe beyond the Earth? Yes, I suspect there is. Don't have any proof. But it's a difficult question to answer because it's hard to say, how frequent that would be. If it's out there, we only have an N of 1 to work with, us on Earth. So it's hard to make proper extrapolations then. Like if this was the only, and this is the problem actually, that bringing this whole webcast full circle, this is the problem that Nibiru conspiracy theorists run into if they're not just trying to scam people. When they run into an object like this, like say they ran into this object, and it was the first one of this kind they've ever seen, that it seems to have some sort of wings coming off of it, and they've only ever seen this and they haven't searched the whole sky. Well, they have an N of 1. They have one example to work with, and they normally jump to the conclusion that it's the only example up there, so it must be proof of Nibiru, because what other object would ever look like this? They've never seen anything like it before. In fact, there are other objects like it out there, and it's not unique, and it's definitely not in the solar system. But they jump to unsupported conclusions in part because they have only ever seen this one. So they conclude it must be the only one out there. So I think it's pretty foolish to conclude we're the only ones out there, if you see what I'm saying. So, have I ever photographed the North American or Pelican Nebula? Yes and maybe. I can't remember if I did Pelican before or not. North American I have, but not really in great quality. I did it with an achromat, not anything fancy. And I never really put that much effort into it because I don't have an APO refractor. That's what I really need, is a wide-angle APO at some point. Alright, let's see here. Am I done with that? I'm done with that. Okay, so I'm going to... You guys can keep asking questions for a bit if you want. I'm going to go ahead and start working on flat fields here real quick before I tear down the equipment. So I've got to flip a couple lights on to do that. I'll be right back. First of all, before I start turning things off, I should probably make sure the auto guider's not running or anything. I'm not going to screw up my camera. yeah, there will be plenty of time to talk about the Drake equation and other such things, Fermi paradox and all that, in future streams, sort of outside the scope of this stream, I guess. For now, I'm just working on taking some flat field pictures, and so I can calibrate this later, probably tomorrow night or whenever. Main thing for me right now is to get main thing I'm trying to get right now are just some relatively decent flat field pictures. Relatively. My method is pretty coarse, which is to say I just turn on some lights, point it at a wall that's relatively evenly illuminated, and take pictures. It's not very fancy. Proper way is to get a illumination panel that evenly illuminates the camera. You also don't want to change the focus on the camera, as that will screw up the calibration. But yeah, trying to do this the way that I'm doing it is not stupendous. It's real hard for me to do this without getting real serious lens flares and stuff from my external lighting. Okay, that's good right there. Yeesh. Okay. So, take some flat fields, and then I can shut down the camera, tear down the telescope, and go to sleep. Do I follow interact with Backyard Astronomy? I think I've interacted with him a bit before. Not much, to be honest. Oh yes, the Lord Rosse telescope. I believe that was the first telescope to be used to actually see the spiral structure of a nebula, which later turned out to be the Whirlpool Galaxy. If I remember right, that was the first telescope large enough that you could actually see the spiral structure with an eyepiece and just your eyeball. I could be misremembering the history of that, but I seem to recall that's the history off the top of my head. Alright, well, flat frames acquired, another GN object, another FU Orionis star collected, and probably some Nibiru Planet X people made very jealous tonight. So, I'll see you guys later. I can think of a number of things I want to try to tackle next time. I'm not sure exactly what we'll go after, but hopefully the weather is taking a turn for the better now with the clear skies and cooler evenings. So until then, I've got to redo the desiccant on this camera and hopefully pull the humidity out of it so we can get the camera down to lower temperatures and produce a lower noise level for next time. Thank you all for watching. Thanks for coming out. And I'll see you all very soon, hopefully. Clear skies, folks.